Okay, here we go on these examples. They're a little bit different. Notice now we're looking at some limits here for the next two as x approaches positive infinity and as x approaches negative infinity. So when we work with these, what we want to do is use kind of a little bit of a different trick, and I'll show you what happens. But here's the thing. I've got the limit of x times sine 1 over x as x approaches infinity. What that's going to give us then is a situation where we get a number that gets smaller inside the sign. So the sign of 0 is going to be 0. And we have a situation where we're looking at x growing larger and larger. So we get the indeterminate form infinity times 0. And we can't have that. And there's really no fraction here to take a derivative of. So one thing that we can do that's basically an equality thing is we can rewrite this limit a little bit differently. And it's actually kind of cool how all this works. We're going to insert in here an h, and we're going to let h equal 1 over x. Okay? H equals 1 over x. So that means now that I have the limit, I don't have infinity anymore, but now I've got h, and as x gets, really large, h actually approaches 0. Okay, so, and again, we're going towards the right hand side of this because we're talking about positive infinity. So I've got the sine of h. Now also though, I've got this x right here all by himself. So what I need to do is solve this equation for x, and the one way that you do that is you multiply both sides by x. So that gets me xh equals 1, and then divide both sides by h. And we end up with x equals 1 over h. So now we put, whoops, not 1 over 2. What was that? Was crazy. 1 over h. So now we substitute in 1 over h right here. Well, what we're doing is we're looking at the limit as x approaches 0 from the right-hand side of the number line, from the positive side of the number line. Okay? And when we do that, 1 over h, as h gets close to 0, gets pretty big, right? But also sine h is interesting. So how do you deal with this? Well, go ahead and write it out like a fraction. We've got sine h over h. And again, as you plug in your zeros here, you get 0 over 0, which is indeterminate. So again, we went from 0 times infinity to 0 over 0. Take the derivative of the top and the bottom. F of x is going to equal sine h. G of x is going to equal h. So when you take the derivative of the sine, that derivative is going to be f prime of x equals cosine h, and g prime of x equals 1. And everything we're doing here, we can also do on this guy, by the way, because they're set up the exact same way. So now my new limit becomes the limit as h approaches 0 from the right of cosine h over 1. Now we can plug that 0 in, and we see that we're going to get 1 for our answer. Now, the thing with part 2 over here, as we approach negative infinity, we're now looking at the limit as h approaches 0 from the left, because we're on the negative side of the number line. But it's the same situation. We're going to end up with sine h over h. And again, we have to follow the same process and take the same derivative. So that's going to be cosine of h over 1, which is 1. So that's a really interesting problem, and we have to set up a pretty unique little inequality, which you don't have to do very often. But this guy right here is important to keep in your pocket because it still keeps our problem true. Okay? And we can use the properties of this to get to L'Hopital's rule so that we can find the limit. And if you graph this and look at it, you'll see that as x grows towards infinity, we do approach a specific number, so that this is how we would show that.